lecture, I am going to throw light on the topic of pointers. See, pointers is one of the most important topics of C language. But before going into the details of pointers, let me tell you about a very basic concept that all your variables and arrays that we people use in our programs, they are stored in computer's main memory, which is also called RAM, random access memory. I think all of you are familiar with this RAM. And see, the disposition of RAM is in such a way that it is made up of hundreds and thousands, millions of memory locations. Each memory location is represented by one byte. For example, this is one byte, this is another byte, this is another byte, and so on. Each memory location is assigned a unique memory address. For example, in this diagram, the first memory location, like it is being represented by one byte. The address of this memory location is 101. That of the next byte, that is memory location, is 102. Then 103, 104, and so on. These are just for representational purpose. 101, 102, I have just given these address numbers as samples. They could be anything. Now all our variables and array elements, they are stored in this RAM. And one thing about pointers is, pointers are basically used to store the memory addresses of our variables and array elements. Now see, a pointer variable is a special kind of variable that stores memory address of a variable or an array. A pointer variable is not used to store ordinary data. There are many uses of pointers. They come in handy when programmers are required to apply dynamic memory allocation. Now, what is dynamic memory allocation? There are two types of memory allocations when we allocate the memory for our identifiers like variables and arrays: static memory allocation and dynamic memory allocation. In static memory allocation, the space is allocated at compilation time, and in dynamic memory allocation, the space for our variables and arrays are allocated at runtime. At runtime means at the time of the execution of the program. This is considered to be a very advanced kind of technique. The pointers come in handy when passing arguments to a function using call by reference. This is a topic that we will cover in our next sections. Now, if a pointer variable contains address of an int variable or an int array element, then it is called pointer to int. Similarly, if a pointer variable contains address of a float variable or float array element, then it is called pointer to float, and so on. Now we will see the syntax of declaring a pointer variable. For example, I want to declare a pointer variable which can store address of an int variable or int array element. So what I will do is, I will declare this pointer variable with any name. For example, I want to take the name PT. So the syntax goes like this. First, we are supposed to mention the data type. Then we are supposed to mention the name of the pointer variable, but preceded with the star symbol. Whenever you see a pointer variable declaration, you will see that it is preceded with star symbol. Otherwise, if I remove this pointer, this star symbol, then it will become an ordinary variable. But now it is not an ordinary variable because it is being preceded with star symbol. So in the next statement, I have declared and initialized a simple integer variable called n. Then in the following statement, I have written pt is equal to %n. Now when I have declared n and assigned it a value, of course, because it has been declared, it will occupy some space in the memory, and that space in the memory of course will be having some unique memory address, right? So when I would write pt is equal to ampersand n, the address of n would be stored into pt. Similarly, if I want to store address of a float variable into a pointer variable, I will have to declare my pointer variable like this. First data type float, then star fp. Fp is nothing else but name of the pointer variable. Again I repeat it, at the time of declaration of a pointer variable, the name of the pointer variable should be preceded with the star symbol. Now here I have got a very simple a simple float variable called temp, which has been assigned some value like 100.998 or something. Then in the following statement I have written fp is equal to ampersand temp. Now ampersand temp means the address of temp, not the value of temp, address of temp would be stored into the pointer variable fp. So always remember, whenever a variable is simple variable, ordinary variable is preceded with ampersand symbol, that donates its address and not its value. Here is another example. I want to declare a pointer to char, that means a pointer variable which is capable of storing address of a character variable. So I would go like this, char star cp. Cp is nothing else but name of the pointer variable. Then I have written char ch is equal to a. What I am doing is I am declaring a simple character variable. Then in the following statement I have written cp is equal to ampersand ch. Again ampersand is address of operator. So address of ch is being stored into cp. Now we will talk about pointer operators. Basically there are three types of pointer operators. One is ampersand, which is called address of operator, and another is star, which is called value at address operator. Then we have got double star, which is called pointer to pointer operator. We will be seeing sample programs so that we can understand all these concepts which I am explaining theoretically. So in those programs we will be using these operators and we will see their significance.